All right, ladies and gentlemen, here we go. I'm going to start chapter 10, and this is going to be a little bit more math than we had last test, so bear with me. But first, we're going to talk about chemical equations. A chemical equation are recipes, how we make things, and it can be either read as molecule or moles. So when we have a chemical equation, we're saying, what we have. Whoops, and let me go back and change my pen. So it's what we have and what we're going to make. And what we mean is that this could be read as molecule and mole. So if we go to the next step, this is a reaction, and we have iron oxide and add aluminum, and we got to add a little bit of heat, and we get iron oxide and iron. And this iron is actually going to be molten. It's called the thermite reaction. It's kind of cool. And when we look at this, we can be read as 1 unit of iron oxide, iron 3 oxide, plus 2 atoms of aluminum yields one unit of aluminum oxide or 2 atoms of iron, or 1 mole of iron 3 oxide, which is this compound, plus 2 moles of aluminum yields 1 mole of aluminum oxide plus 2 moles of iron. Now, I want to point out that this is what I call the microscale. We're looking at just units or molecules or atoms reacting, and where this one is moles. 6.02 times 10 to the 23rd atoms of or molecules of things. So when we look at this can actually describe both micro and macro scale. It's just how you, as the chemist, need to look at it. And for this class, we're going to do a lot of macro work, looking at moles. And when we use these chemical equations, and on this chemical equation, let me point out that this are the reagents. And these are the products. And we also may say reactants also. Another word for reagents. So these two terms are used interchangeably. And we need to convert the moles to grams. So when we use, because in this chapter, we'll be figuring out what we need to have. Do we need to have how much reagent we have, how much products we're going to make, how much we have initially. And so this is what we're going to use. So given one value, if we're given 10 grams of iron 3 oxide, you can figure out all of these 3 steps. 1, 2, 3. So that's what we need to do. And then after we do this, right now we're going to switch gears and talk about 5 different types of reactions that you're going to see in these chapters. And the first type is going to be combination. And basically we're adding one molecule plus another, and they're going to combine together to form the third. And something like this is hydrogen, and we're going to have 2 of these plus O2, and we're going to have H2O. This is a combination. A plus B equals C. This is what we call combination reaction. I want you to learn the terms and figure out from these type of combination reactions what the product is. And here's your chemistry, guys. This is what we have to do. And these are the 5 major types of reactions. There are others, but this is what we learned in this class. Decomposition. Here's another one, and we have mercury oxide. We've got 2 of these. And we add a little bit of heat. This is a nice reaction to see because this is red, and you end up getting a silver product plus oxygen gas being released. And unfortunately, this is kind of dangerous and nobody wants to deal with it, so we don't do this reaction anymore. But this is decomposition, where we have A goes to B plus C. And all of these reactions, at the most part, are pretty much, they go from left to right. They go to completion. Single displacement. This is usually when we add an acid or base. So we have aluminum plus HCl. And we've got, I'm going to put 3 of these. Oh, no. 2 and 6. Sorry. I've got to make sure I do this right. And we got 2 AlCl3 plus 3 H2, and yes, that's my cat. So this is single displacement. We're replacing the hydrogen with a metal. So this is a metal. And this is usually acids. It can be a base. And this is my compound. And we usually end up with hydrogen gas at the end. So single displacement. Double displacement when we have 2 compounds. So we have lead nitrate, PbNO3 plus 2 NaCl. And we have PbCl2, which is a solid, plus 2 NaNO3. And what happens is these 2 are in solution, and you get a solid out, and this remains in solution. Double displacement with this and this switch, and these 2 stay, but this goes with the sodium, and this goes with the chlorine. Double displacement. So we usually go AB plus CD yields AD plus CB. I gotta make sure I do this right. So 2 compounds yields 2 compounds. One's a solid, one is a solid, one, and the other isn't. And all we're doing is just switching these 2 places. Whereas a single displacement, we got a metal, a solid, and an acid. And this compound may or may not be a solid. It's probably in solution as well. And then we have this as a gas. Combustion is our last one. And that is, this goes C2H6 plus O2 yields CO2 plus H2O. So we're always having something burning. It always has oxygen. Here we have carbon and hydrogen. So if you see these 2 together, you're going to get some number of this. And if I remember, this is going to be 2. And this is going to be 3, 4. This is going to be 3, 2, and then let's see, we're going to have, I need to balance this out, and I'll show you how to do this next slide, but that's the balance equation. So they're burning, and you get this. Also, I want to point out, you're going to see this on a lot of the slides from now on. S means it's a solid. AQ means it's dissolved in water. And we'll call it aqueous. That's where the AQ comes from. L is a liquid. And G is a gas. These are called the states of matter, and they're usually written as a subscript after the number. All right? And to review, go back to the last test and review these two steps, because we're going to be doing this a lot in this chapter.